De La Vega, Hamil, Landar,
Landar
Manoob,
present, sir.
Present Manoob, sir.
Marentes, Unahon,
Present, sir.
Oro,
Present, sir.
Present, sir.
Unahon,
Present, sir.
Pahente, Pascual,
Present, sir. Pahinte.
Present, Pascual,
Sagi,
sir.
Sagiyahon,
Present, sir.
Present Pagyakan, sir.
Pitos,
Present, Sir Pitos.
Salvan, Richel Ann, Sarong, Sitier,
Present,
Timba,
Sarong, sir.
Sitier, Timba, Tobiano,
Present, Timba,
Batoy,
sir.
Present Tobiano, sir.
Batoy,
Present, Batoy,
Bayudan,
sir.
Present
Bayudan,
Bayudan.
Piquero,
Present, Piquero, sir.
Arias, Castillo, Clement, De La Vega, Hamil,
Present, Hamil,
Salvan,
sir.
Sitier. Kasi wala tawag palikog ko ang chat. Asilo. Asilo. Espiritu. Okay, so let me share my screen, my presentation. Actually, this evening we'll have a koan. We'll have a further discussion on what we have discussed last Saturday on the free vibration response of a single degree of freedom system. So just a minor review sa atong discussion. We have two types of vibration. We have the free vibration and the forced vibration. And for the free vibration response or free vibration system, we have two conditions. We have the undamped conditions and also the damped condition. For the damped condition, we have the underdamped, critically damped, and the overdamped. Now for the undamped free vibration system, so pasabutan na that our equation of motion nga mass times the response acceleration plus the coefficient of damping times the response velocity plus the lateral speed plus k times the laka na sir. Lateral stiffness times the lateral displacement u of t is equal to 0. For the undamped free vibration, our c or our damping coefficient is equal to 0. Sa ato pa, our equation of motion will become mu double dot of t plus ku of t is equal to 0. Now, if you remember our auxiliary equation for this one, that is r squared plus omega squared is equal to 0. So we will have r squared is equal to negative omega squared, and extracting the square root on both sides, natin makuha ang roots sa itong auxiliary equation, which is equal to negative or positive and negative I omega. Now having being able to obtain the the roots, would be able to substitute this atong general solution na u of t is equal to g1 e to the r1t plus g2 e to the r2t. Or we'll have g1 e to the positive I omega t plus g2 e to the negative I omega t. And applying the Euler's equation, in this condition, we will have the Euler's equation is E is equal to positive or negative I omega t. We will obtain a trigonometric function na cosine omega t plus minus I sine omega t. So, diyan, no? Actually, we're supposed to discuss the detailed steps on the general solution of this equation of motion, but the time will not permit us. I will just give you the brief solution or the final answer rather for the undamped free vibration system and for other system. So for the undamped free vibration system, the equation of motion or the solution, let's call this our method A. Our u of t is equal to u naught cosine omega t plus u dot naught over omega sine of omega t. This will be our lateral deformation for the undamped free vibration response. And our response velocity, that is equal to negative omega u naught sine omega t plus u dot naught cosine omega t. So let's say this is our method A. Actually, if you will be able to memorize this one, this is quite simple in solving the problem. Kung inyo nang memorize, actually, diretso na ninyong isubstitute ang initial displacement as well the initial response velocity and inyong calculated nga natural frequency. And eventually, you'll come up sa answer na to for the lateral deformation and as well the response velocity. You can also use the other one, no, katong other method nga akong discuss, method B, or the other solution, katong u of t is equal to alpha sine omega t plus beta cosine omega t. And for our response velocity u of t, u dot of t is equal to, we'll have omega times quantity negative alpha. So, now na sulat si cosine, no? For unity of solution. Pwede ka po siya, but for unity of solution, and then mamalibog that will become alpha cosine omega t plus beta sine omega t. And for our response velocity, that we will have u dot of t is equal to omega times quantity negative alpha sine omega t plus beta cosine omega t. So, pwede gyapon nga kani ato ang gamiton. So for this one, no, the method B is dali lang siya memorize because we will have only two unknowns, alpha and beta. And kato sa method A, it will give us the fastest solution kay nakabutang na dira kung kinsa si alpha o si beta. Now for the underdamped free vibration system, we have the root of the Euclidean equation. Katong when the damping coefficient C is not equal to 0, we will have negative psi omega plus minus omega square root of psi squared minus 1. Now, si underdamped, may tabo ni siya when our discriminant C over 2m squared minus omega squared is less than 0. Or our damping coefficient C is less than the critical damping 2m omega. Or when our psi or the damping coefficient is less than to 1.0. Now, kung yung tanaw din sa itong equation, no, if the psi is less than 1, actually this part here sa ito ako, discriminant will give us a negative square root. So for the underdamped condition there, we can write that our root is equal to negative psi omega plus minus I omega square root of 1 minus psi squared. So kani si I, mo to siyang part nga square root of negative 1. And for simplification, di ba, we have the damped natural frequency which is equal to omega square root of 1 minus psi squared. So dali na lang din kayo memorize so that the root for the underdamped free vibration system auxiliary equation will become negative psi omega plus minus I omega d. Same step yapon siya with the undamped free vibration. No, you substitute this at on general solution at G1 e to the R1t plus G2 e to the R2t, and then you apply the Euler's equation, and then you can solve you will be solving for G1 and G2, then you will have a general solution for the differential equations under the free vibration system na. So this is our method A again. U of t is equal to e to the psi, you have the e to the negative psi omega t times quantity alpha cosine omega dt plus beta sine omega dt. And then our response acts of velocity u dot of t will become e to the negative psi omega t. No. This is our method A. So this is not to A sa A koan. Let's not use the alpha and the beta arbitrary constant. Let's try to write first the whole solution. So that is u of t, or the lateral deformation u of t, is equal to e to the negative psi omega c times quantity u naught cosine omega dc plus quantity u dot naught plus psi omega u naught over omega d times sine omega dc. This is the general solution for the underdamped free vibration system. So for method A, no, dali na kayo ni makuha ang answer na to because we have actually the given u naught sa itong problem na po given din nga u dot naught. Ang isolve na lang ninyo will be the omega and the omega d. And then you just input that in the equation and eventually you will have your answer. For our response velocity, u dot of t, this will become e to the negative psi omega t times negative omega u naught sine omega dc plus quantity u dot naught plus psi omega u naught cosine omega dc minus psi omega u of t. So, mapo ni siya sa response velocity. Now, for the method B, itong mas dali, no? The simplified version. We'll have u of t is equal to e to the negative psi omega t times quantity alpha cosine omega dt plus beta sine omega dc. And our response velocity u dot of t is equal to e to the negative psi omega t omega d times quantity negative alpha sine omega dt plus beta cosine omega dc minus psi omega u of t. This will be our method B. So, mo to siya, no? Method A is medyo taas in horizon, but dali na lang kayo siya ma-solve. Diretso na ninyo ma-solve if you have the omega and the omega d. But for the method B, mas dali siya memorizon, pero medyo taas inyo ang pag-solve. So later on, na siya gamiton sa ito ang solution. Para ma-compare ninyo. We have also our case B for the damped free vibration system. Critically damped. So critically damped, it happens when our C over 2m squared minus omega squared is less than 0. So the determinant is less than 0. Greater equal to 0 rather. And our damping coefficient C is equal to 2m omega. And our psi is equal to 1.0. So if tanawin niyo sa auxiliary equation, again, R is equal to negative psi omega. We have the negative psi omega plus minus we have omega square root of psi squared minus 1. Diba? Now, since psi daw is equal to 1, so 1 squared minus 1, that will become to 0. Or sa atong determinants daw, that is equal to 0. So this part, this is equal to 0. So atong root of the equation, auxiliary equation will become r is equal to negative psi omega. And since psi is equal to 1, so the root will become negative omega. Now, the general solution for the critically damped u of t is equal to g1 e to the negative omega t plus t g2 e to the negative omega t, or simply u of t is equal to e to the negative omega t. If we factor out c e to the negative omega t, that will become g1 plus t g2. So the general solution for this one, ang katungkuan, we have the exact value. We will have, or the method A rather, we will have u of t is equal to e to the negative omega t times quantity u naught plus quantity u dot naught plus omega u naught times the time t. This will be the lateral deformation if the system is a critically damped free vibration system. Our u dot of t, or our response velocity, will become e to the negative omega t times u dot naught plus omega u naught minus omega u of t. And for our method B, so katong simplified nga version, so we will have our u of t, or the lateral deformation, u of t is equal to e to the negative omega t times alpha plus beta t. So, puro kayo siya tanaw, no? And then our u dot of t, that is equal to beta e to the negative omega t minus omega u of t. This is for method B. Dali kayo. Among the free vibration system, ang pinakadali ikuan, dugdungon nga formula will be the critically free damped free vibration system for both method A and the simplified version. And for the kuan, the overdamped system, no, when our R, this happens when our C over 2m squared, quantity C over 2m squared minus omega squared is greater than 0, or our damping coefficient is greater than 2m omega, or our psi is greater than 1.0. So the roots of our auxiliary equation will just remain at r is equal to negative psi omega plus minus omega square root of psi squared minus 1. So since si psi is greater than 1, so kung minusan na nimog 1, that will become, if that will become a positive integer, and compared sa itong underdamped na negative siya, this one will be a positive number. So pasabot, there is no complex number here. So the root of the auxiliary equation kanisha, this will be substituted sa itong general solution nga u of t is equal to g1 e to the r1c plus g2 e to the r2t. Now, using method A, the overdamp, or the lateral deformation, the overdamp u of t, that is equal to e to the negative psi omega t times quantity 1/2 times quantity u naught plus u dot naught plus psi omega u naught over omega square root of psi squared minus 1 times e to the omega t square root of psi squared minus 1 plus 1/2 times quantity u naught minus u dot naught plus psi omega u naught all over u omega times psi square root of psi squared minus 1 times e to the negative omega t square root of psi squared minus 1. Ano siya si lateral deformation ni overdamped free vibration system. So kung taas na gani kasi u of t, actually the pinakataas nga po general solution will be the overdamped free vibration system. So kung taas na gani kani ang u of t, much more ang u dot of t. So for the overdamped free vibration system, no, we can tolerate to use the method B, or the simplified method. We have the u of t is equal to e to the negative psi omega t times alpha e to the omega t square root of psi squared minus 1 plus beta e to the negative omega t square root of psi squared minus 1. So kung nyo i-compare, no, this one, method B and method A, lahiragid kayo. Mas mubo si method B, and mas gamay po nga variable ang inyong isulat sa inyong solution, and mas dali mo solve. And our so this will be our method B, simplified lateral deformation for the overdamped free vibration system. For the response velocity u dot of t, kuha na siya. This is omega e to the negative psi omega t square root of psi squared minus 1 times quantity alpha e to the omega t square root of psi squared minus 1 minus beta e to the negative omega t square root of psi squared minus 1 minus psi omega u of t. So, mo ba ni siya si response acceleration using the simplified method. So, medyo taas-taas siya, pero much more na lang if katong, yes, Mr. Batoy?
Sir, kanang puan sir baka ng psi bitang squared na sir. Square root of psi minus square
Psi
root of
squared,
psi
square root of
squared.
psi squared minus 1.
Ah, okay, okay.
Okay. So, mo lang to siya, no? That is just a brief recap sa ato ang discussion last time, and kuan. Additional lang ako, equation of, or the solution is, general solution for the equation of motion is itong sa method A. So, ito magdugay-dugay, no? Let's have our first sample problem. So we have here a water tank has a mass M, supported by four steel columns, each with stiffness K, Young's modulus E, and central moment of inertia I, length L, and structural damping C. Initial deformation U naught is equal to negative 400 millimeters, and initial response velocity U prime naught is equal to 300 millimeters per seconds. And then we were asked to find the natural angular frequency, the damping ratio psi, and then the deformation and response velocity at time is equal to 5 seconds. Okay, for our first example, we have a water tank that has a mass M, supported by four steel columns. So take note anong ano, kung pila ka columns yung gihatag. Okay, actually it will affect the natural angular frequency of our structure. So lahi na frequency kung isa ra ka column versus upat ka column. Like po ng stiffness. We have also a stiffness K, and then natin lang Young's modulus E, I, L, and C. And not given na itong initial displacement and initial response velocity. So first na itong nakuha is the natural angular frequency omega. But before that, atos na tanawon what type of structure is this? Is it undamp or undamp? So klaro kayo no that our C is equal to 0. So when C is equal to 0, therefore our structure is that is an undamp na structural system. So undamp man siya. So we will use the equation of motion or the general solution for the undamped condition. Okay, so let's start our solution. So we're asked to find the natural angular frequency omega. And kabalutan nga si omega that is equal to square root of K over M. Now, natin given nga mass that is at 5,000 kilograms. The question is we don't have the K. So we need to solve for the lateral stiffness K. So for one column, so sa kaposte, ato ang lateral stiffness K, that is equal to 12 EI over L cubed. So we will have 12 times our E. Young's modulus is 200 gigapascal. So giga, that is 200 times 10 to the 9. And then Pascal is in Newton per square meters. Then the I, the moment of inertia, we need the I. So our I dive is given 178,645.833 millimeters to the fourth. All over L cube, or L, or the length or the height of the system is 3,500 millimeters, or 3.5 meters cube. Now, ang unit dapat ni stiffness K should be in Newton per meter. So, to obtain a unity of the units, so we need to remove, we need to find a way in such a way as millimeter by millimeter, so that will become, so we just multiply the whole equation with 1 meter per 1,000 millimeters, and then raise that to the fourth power. Nalan tayo stiffness K, which is equal to, pila, Mr. Pahente? Pahente?
Wait lang, sir. Uh,
10,000, sir. Newton per meter.
Pahente akong gitungutan na, Mr. Batoy.
Lapit na, sir. Wait lang. 10,000 ako, sir.
Yes. So our structure is, or one column has the natural or the lateral stiffness equal to 10,000 as a unit. Mr. Batoy.
Newton per meter, sir.
Or
Newton per meter square.
say Newton per meter. Per meter naman
Hindi
ako.
ko talaga. Ay, kilonewton per meter? Ay, charot. Buong kasi.
Or, pato na i-relate sa Newton, that is kilogram meters per second squared. Yan na may per meter, so napati over m. Makancel na nimo ang 2 ka meter. So, usa ka unit ni stiffness is kilogram per second squared. So, di mo kontaranta o giyatagan mo kilogram per second squared or Newton per meter because they are just the same. So, our K is 10,000 Newton per meter. Now, take note, this is for one column. Yan na may upat ka steel columns daw. So, we need to multiply. So, we need to get the equivalent stiffness K. So, we just multiply the K to 4. So, we will have a stiffness nga 40,000 Newton per meter. Now, na K, we have M. We have the mass M. So, we can solve for the natural angular frequency omega. That is square root of 40,000 Newton per meter over 5,000 kilograms. So, natin tayo omega, which is equal to, pila man, Mr. Piquero? Piquero.
Wait lang, sir. .83, sir.
Up to 6 decimal places, pila, 2
2.828427.
sa unit.
Kilonewton, sir.
So, ang giingon na tumiyagi. This is, kung akong i-write ang unit, diba natin Newton per meter per kilogram. Kana si Newton per meter, that is kilogram per second
Meter.
squared over, ano pa po naman, over kilogram. So, makasa si kilogram, natin tayo mabilin nga square root of 1 over second squared. Pila na lang man na. That is 1 over seconds. Or radians over seconds. So, our unit for the natural angular frequency is radians per seconds. So, this will be the answer for the natural angular frequency. We have 2.828427 radians per seconds. Okay, thank you for your answers, no Pahente, Batoy, and Piquero. So, na natin omega. Next is we need to find the damping ratio. Damping ratio is just psi, which is equal to C over 2m omega. Now, our C is 0, so ato pa there is no damping ratio. that is just equal to 0. Next is the displacement of u at time is equal to 5 seconds. So we are asked to find the u, the lateral deformation u at time is equal to 5 seconds, and the response velocity u of 5 at u of t is equal to, at 5 is equal to 5 seconds, time is equal to 5 seconds. So, mo na din siya. First device, we try to determine what type of free vibration response system na nasa tuwa. No, kasi nasa problem. Moto siya nga, ang kanya siya nga system, this is an undamped free vibration response system or structural system. So that's why we need to use the equation or the general solution for the undamped free vibration system. Now, using method B, our u of t is equal to e to the, no, there's no e, but we have the alpha cosine omega t plus beta sine omega t. So, saan mo na ito na pag-solve? We need to have our initial condition. So, mo ito siya, initial conditions. So, may initial condition na ito. At time is equal to 0, ilan man na itong lateral deformation. Our lateral deformation u naught is equal to negative 400 millimeters. Our u dot naught is equal to 300 millimeters per seconds. So it is very important to take note of their units. Kay W meter per second ang gihatag diya. Ang isa kay naka millimeters. So wrong ya pa ninyong answer. Let's be correct in yung steps. So if we try to substitute these initial conditions at ang general solution, so we will have negative 400 is equal to alpha cosine of 0 plus beta sine of 0. Now, cosine of 0, that is equal to 1, and sine of 0 is equal to 0. So now I can answer that the alpha is equal to negative 400 millimeters. Next is, since how many unknowns, we have the alpha and the beta. So 2 unknowns means that we need 2 equations to solve the unknowns. So the number of unknowns should, or the number of the equations should be equal to the number of unknowns, or the number of unknowns should have 2 equations para ma-solve sila. So we have we already determined the alpha, and next is kinahanglan to makuha si beta. So next na itong equation will be the response velocity. So the u dot of t, that is equal to omega times quantity negative alpha sine omega t plus beta cosine omega t. Now, the initial condition at time is equal to 0. Our initial response velocity is equal to 300 millimeters per seconds. So we have this equal to omega times quantity negative alpha sine 0 plus beta cosine 0. Again, no, sine 0, that is equal to 0, and cosine 0, that is equal to 1. So we have 300 is equal to omega times beta. And we have beta is equal to 300 over omega. So our beta is, pila man ni Sir Tubiano? Tubiano.
Sir, pila itong values omega, sir? Pwede pa back sa katungkuan.
2.828427.
$106.066, sir.
Up to 6 decimal places.
106.066022.
It's a unit. It's a unit.
MM, sir.
Pag
mm per
sure.
seconds.
Pag sure. Sa man
Ay,
yun?
wait.
mm per seconds or mm?
Millimeter per second, sir.
Anong naka-into millimeter per seconds?
Ay, wait, sir, wait. Ano siya?
Mm ang unit ni millimeter ni kuan yan din.
Ang 300 is mm per seconds.
So,
Rad per second.
mm per second over sa unit ni omega.
Rad per second. Ito siya, sir.
Radians per second. See that?
Ah,
Radians per seconds. Numerator as the reciprocal of the denominator. Ilan na lang may nabili na unit?
millimeter over rad, sir. Radian.
Millimeter na siya. Kanang
Okay,
radians.
so,
Kuan na na siya kay pasabot nga naka-radians yung answer, wala siya naka-degrees. So, kuan na
okay.
siya ka. Di ba atong unit is actually that is 1 over seconds mo na siya or s to the negative 1 yan na siya. So, pwede po na siya tawag na radians per seconds.
Okay, sir.
Okay, so
Thank
ang
you,
unit
sir.
is in millimeters or
Millimeter.
beta is in millimeters. So this is not always the case sa kay na other nga beta nga probably millimeters per second, so not depende. So na natin alpha, we have the beta. So masabi na to si kuan U. Our alpha is negative 400 millimeters. Our beta is equal to 106.066.022 millimeters. And then our omega t or our natural frequency times the time is ilaw to siya. We have the 2.828427 times 5 because 5 seconds mas ako na lang sulat pa di. We have 2.828427 radians per seconds times 5 seconds. So makaso sa seconds, then we are left with 14.142135. So this is the omega t. Ito na mas si u of t. So we have again u of t is equal to alpha cosine omega t plus beta sine omega t. So our u of 5 or the lateral deformation of 5 seconds, not tayo negative 400 cosine of 14.142135 plus 106.066022 sine of 14.142135. O Mr. Non, pila man ang kuan lateral deformation after 5 seconds? Unahon.
Wait lang sir, kaya gusto pa, kaya ikalki pa sa
Okay.
one 108.051928.
Yes. And that is the correct answer. Our lateral deformation after 5 seconds is equal to sa may unit na yung tawag Mr. Unahon.
Per second na sir, kay cancel out po ng mm. Ay, mm squared per
Sa
second sir. mm squared per second.
Ano man? Ano man? Kung bitaw kay dili mo magtubag answer ba nga wala unit. Naignan gid mo ko sa mana 108.05 apples or banana.
Ay, mm squared. Mm per second na sir.
Kasi unit ni alpha. Si alpha is
sir.
negative 400 millimeters. Okay. Kasi unit ni cosine 14.142135.
sir.
Wala na siya unit. No, wala na unit, di ba? Plus, unit ni 106.066022 is millimeters. Ani, wag pa siya unit. So, sa may unit? Final unit na to.
Sir.
Yes, millimeters na lang. Iwanan niya siya to ang lateral deformation after 5 seconds. Next, response velocity. Ang response velocity u dot of t, that is equal to, you have the omega times quantity the omega times quantity negative alpha sine omega t plus beta cosine omega t. This is equal to 2.828427 radians per second times quantity negative of a negative 400 sine of 14.142185 135 guy 14.142135 plus we have the 106.066022 cosine of 14.142135. Okay, Ms. Marentes, ila tong response velocity?
1,129.866426, sir.
Sa man na siya?
Ay, sir. Sudo po.
1,129.866426. Unsa man ni siya? So may unit ano eh?
Wait lang, sir. Wait.
Velocity man, response velocity. Sa may unit sa response velocity.
Millimeter per second, sir.
Yes. Very good. Pasay. Millimeters per seconds. Ano siya to ang response velocity after time is equal to 5 seconds. So, paano ito siya ang kung ano steps? Now, let's try method A. Method A, or u of t is equal to, you have the u naught cosine omega t plus u dot naught over omega sine omega t. Our u naught, that is negative 400 cosine of 14.142135 plus our u dot naught, that is equal to 300 over 2.828427 sine of 14.142135. So kanino kung method A itong gamiton, diretso na tanan natin the answer nga 108.051928 millimeters. So mas dali siya makakuha og answer compared ni method B. Kung tanan is method B, natay ko ang general solution, we have the two unknowns. So ato pang pangitahon ang two unknowns, si alpha si beta, no? We need initial conditions. And then after makuha na itong two unknowns, ay pwede mag-solve sa tuang initial, ay pwede mag-solve sa tuang lateral deformation or the lateral displacement and sa tuang response velocity. What is the method A nyo ang gamiton? Automatic. Okay, just input the initial velocity, initial deformation, and then eventually you will then you'll have an answer right away. Same also with our response velocity. You know, next, before we proceed sa sa next example, alas ako i-share sa inyo ano. Let me share you another presentation. So as you can see, no, we have a graph here. This is a sinusoidal graph. And then this is a the graph of the under the an example of a under the free vibration structural system. So yung isa yung pakibalo nga under damp, di na siya undamp. So balik no, si undamp, there is no damping. The oscillations will remain the same perpetually, no? So forever and ever, ang oscillation di na siya mugamay. Maintain yun na siya. For the underdamped free vibration system. Okay, sir. Okay, ang kuan man ka, ang motion or ang oscillation ni kuan, ang damp is perpetual. The same ra pag siya perpetually. Isa po ni magkaibalo nga underdamped na siya, dili na siya critically damped or overdamped. Kung ang imong system is critically damped na siya, ang graph niya na after initial displacement, ang iyang graph or iyang oscillation is ingani ang direction. So after displacement, direction na rin siya of rest. Same also with the overdamp. That's why nakaingot nga si underdamped di siya. Only the underdamped free vibration response system ang naay property nga same ingani. You have the initial displacement or deformation, and then magkagamay, and then eventually it will come to rest throughout time. So this is the underdamped, the graph of the underdamped free vibration response. So actually this one, we call this the decay of free vibration response. So may nga nitag decay, that is the loss of energy. So muna siya nga nakagamay ay ang deformation because nagka-loss ang iyaang energy, and then eventually it will come to a stop or it will rest. So here we have a natay ginatawag nga logarithmic decrement. So before that, ang kaning natay if we take the ratio of two successive peaks. So let's say if to ratio si U0 o si U1 for the underdamped vibration system sa yung sinusoidal graph, actually that is equal to the e to the negative 2 pi psi omega over omega t. Kani siya, mo ni siya ang decay sa ato ang system. Now, if you take the natural logarithm of that, natin tayo ginatawag nga logarithmic decrement. Yung symbol is delta. So logarithmic decrement is just equal to natural logarithm of this one, ui over ui plus 1, or 2 pi psi omega over omega t. So sa may isa na ni logarithmic decrement. Okay. Ito na dito sa to ang next example. Ano siya? In the figure, it is observed through experiment that the amplitude of free vibration of a certain single degree of freedom structural system decreases in 5 cycles from 55 millimeters to 17 millimeters. So, we makita ano nga natay here, looking at the problem, we have from 55 millimeters to 17 millimeters after 5 cycles. So, saan na mo pagkuha sa kuan? Sa iyang damping ratio, stiffness K, omega, o omega D. Nga ang omega, that is square root of K over M man. Dayon, si K pa dyan, wala pa dyan given 3, no? We don't have any values for the K or for the lateral stiffness diya. Nasamot na mag-12 EI of L cubed ta, walay L, walay length, walay Young's modulus. There is also no central moment of inertia. So, na din siya nga atong magamit na dahil si logarithmic decrement. So from the equations na logarithmic decrement, we'll be able to come up with those unknowns. So we have to find the logarithmic decrement first, that is delta, and then our damping ratio psi, the column's collective stiffness K, the undamped angular frequency, and then we have also the damping coefficient C, and the damped angular frequency omega D. So first is let's draw the figure. So we have a single degree of freedom system again. And then we allow this system to vibrate. Initial oscillation, we have 15 millimeters. So natin na siya given ng length. This is 3.5 meters. So this given ng length, bigyan pa natin siya ng musog. Sa other given, the mass is unknown, stiffness K is unknown. For not the other given, we have the number of cycles, N is equal to 5. And what else? Initial displacement, we have U naught is equal to 55 millimeters. Pagkahuman sa 5 ka-cycle, so that is U5, which is equal to 17 millimeters. And then we're asked to find the logarithmic decrement. So actually, na ito look up formula sa logarithmic decrement. We have the delta is equal to natural logarithm of U naught over U1. So wala lang ako siya UI over UI plus 1, but it indicates two consecutive successive peaks or amplitude. U naught over U1. Tapos tayo 2 pi psi omega over omega t. Katulungan nga formula, we have the natural logarithm of U naught over UN over N. Kana si UN, mo na siya ang cycle after N cycles. Si N is kung pila ka cycle. Now, kung tanaw ni mo, si first nga formula, di na ito na magamit. Yes, we have the U naught na 55 millimeters, pero wala man tayo U1, U sub 1. So, di na ito siya magamit. Samot na ning second nga equation. Wala tayo psi, ato ganin pangitaon. Wala tayo omega, we do have also omega d. But kaning third nga equation, natay U naught, natay U or deformation after pilak after N cycle, and natay number of cycles. So we'll use the third form equation to solve the logarithmic decrement. So basic kayo, that is delta is equal to the natural logarithm of 55 over 17 over the 5 cycles. So pila man atong logarithmic decrement, Miss Clement? Clement? Absent na si Clement? Asilo?
Sir, 0.234, sir.
Sa to? Up to 6 is
0.2.
is pila man?
Ay,
Okay,
wait.
very good. 0.2 na. 0.234. Up to 6 is what, please? Pila man?
823 po, sir. Ay, 824.
Yes, 8 to 4. So this is our logarithmic decrement. So dali lang kasi logarithmic decrement, no? Formula based ra. Now is, kung tanata, pila daw ang damping ratio. Sa mo na rin magpa-atras na ta, mag-back engineering ta. So B, we are asked to find the damping ratio psi. Kabalo ta si psi, that is C over 2m omega. Si mass kay unknown, si omega kay unknown, si C or damping coefficient C is also unknown. Saan mo na nato? Pero natay, logarithmic decrement. If you remember, ang ikaduha nga formula ni logarithmic decrement, that is 2 pi psi omega over omega d. Now, saan mo na nato, sir, ng omega omega d kay unknown ng sadna? Amo na na siya ron. Dapat gamito ninyo inyo ang ano siya. So we have the, if you remember, our omega d or the natural angular frequency, that is equal to omega square root of 1 minus psi squared. So kung inyo na i-cross na nimo si omega d dito, o kaning naka-square root on the other side, natay 1 over square root of 1 minus psi squared is equal to omega over omega d. So familiar? Sa to pa, omega over omega d is equal ani. So we can rewrite na dahil ang logarithmic decrement. Delta is equal to 2 pi psi times 1 over square root of 1 minus psi squared. Now, dili man taganahan nga na-equal square sa denominator, ato na i-cross na to because ilabay na to na dito and also si delta on this side. So, natay square root of 1 minus psi squared is equal to 2 pi psi over delta. Now, para mawala sa square root, kasi psi mo na ito pangitaan with square both sides. Nalang tayo 1 minus psi squared is equal to 4 pi squared over delta squared psi squared. And next button. If we're gonna combine like terms, so we will have 4 pi squared over delta squared psi squared plus psi squared is equal to 1. Factor out na to si psi. Si psi man ito pangitao natin tayo. Psi squared times quantity 4 pi squared over delta squared plus 1 is equal to 1. Or psi squared is equal to 1 over quantity 4 pi squared over delta squared plus 1. If we extract the square root of both sides, natin masolve nga psi is equal to 0.037347. Ganun na rin siya. Ano na tayo? Damping ratio. So we have only 1 minute left, no? Pero ato last na rin humanon. Tanan. So na natin psi, we have our logarithmic decrement and then we have our psi or our damping ratio taken from the equation nga gihatag ni logarithmic decrement. Next, we are asked to find the omega. Si stiffness K. So kani si stiffness K, C. So if you remember, no, we have the system. We have the height, 3.5 meters. Natin siya given, other given pa. Ang iyang columns daw is 4 ka, A36 steel. So A36 ang steel, ang iyang modulus automatic gigwagiatag, that is 200 gigapascal. And then apoy dimension giatag, 75 millimeters by 150 millimeters by 10 millimeters. Na given nga mass, that is equal to 1,223.242 kilograms. So kung ato i-draw ang section, ingani ni siya. You have 75 millimeters. Height niya is 150 millimeters. But this is a hollow section. And iyang thickness is 10 millimeters. Now, the formula ni K is equal to 12 EI over L cubed. Natay L, natay E. Ang I na lang is, kung saan itong gamiton? Pwede man na siya nga, CI, pwede siya nga katong 1 over 12, yeah, 75 times 150 cube. Or pwede po nga 1 over 12, 150 times 75 cube. So, sa may gamiton. So, kung ato ning kung ano, atong hunaw-hunaw ayo, if wala i-indicate ha, ang motion or ang kuan, ang punta na to, ang earthquake, or ang applied dynamic force, or let's say the earthquake na lang, pwede siya mawagi diha along that axis and along this axis. Kung along diri nga axis mawagi ang ato ang force, ang inertia na is 1 over 12 times 150 75 cube. So ang gravity sa force is kani siya diri, the 75 millimeters, this is millimeters. Now, pag kani ang direction nga ito i-analyze, that is 1 over 12 times 75, 150 cube. Now, kani siya, this is the ideal. Pero kung mong tanawon, kani siya is gamay og inertia. Gamay siya og resistance sa deformation. Sa ato pa, this one, this direction is our weak axis. Okay, weak man nga axis, dapat mo na to ang gamiton nga I. So this one. To incorporate or to include sa itong system nga gisabot na to siya nga mo ni siya ang iyang stiffness on the weak spot niya, on the weak side niya. So our K, we have the K is equal to 12 times 200 gigapascal, that is 200 times 10 to the 9 Newton per square meters, then times I. So that is times 1 over 12, 150 BH cube, times 75 cube. Now, kanimong system, that is a hollow section. So dapat, kuhaan na to og inertia ang kaning dako ug kaning minus kaning open, kaning hollow. So we have the dako nga part, 1 over 12 times 150 times 75 cube. Atong i-include ang open nga part. That is times 150 minus 20 times 75 minus 20 cube. So this is in millimeters. All over, ang L niya is 3.5 meters cube. Now take note na naka-millimeter ang I, so din na lang. Mag-multiply ta og 1 meter over 1,000 millimeters and to be raised to the 4th power. So nga ng 150 minus 20 o 75 minus 20 nga 10 millimeters naman ang thickness. So ano siya? Exaggerate lang nato ang thickness lang. So this is 10 mm. Kaya ito mapangitag inertia kaning dako o kaning gamay. Now, ang dimension na ning gamay, that is 75 minus 10, kay 10 man siya diri, dito part, minus 10 pag yun, diri nga part, para makuha na to ang length ani. Same also diri. That is katong dako nga 150 minus 10 diri, minus 10 diri. So that's why we have minus 150 minus 20 and 75 minus 20. So now natin take K, or stiffness for a single column, that is equal to 194,297.3761 Newton per meter. Now, upat man ni sila ka column, we multiply the collective stiffness is just equal to 4 times our K. That is equal to 777,189.5044 Newton per meter. So, yan na, i-take into consideration yun ninyo kung pila nga po column. Okay, as you can see, the more columns we have, the stiffer the structure is. Pero ang depende po na sunod ang given is dili individual column. Ang iyang gihatag is equivalent K, collective stiffness K, no? Equivalent K or the collective stiffness K, that is the stiffness of all the columns combined. So dili na mo guys for ana. Diretso na. So that is our answer for the column's collective stiffness. Next is the undamped angular frequency. Si undamped, ano siya, si omega. Saan na to? So, di ba we have the omega is equal to C over 2m omega. No? Si omega is just the square root of equivalent stiffness K over mass. And natin K, that is square root of 777,189.5044 Newton per meter over the mass nga 1,223.242 kilograms. Na. We will have omega or the undamped angular frequency 25.206194 radians per seconds. Matik na. Next is the damping coefficient psi. So si psi is just equal to, damping coefficient C. Psi is equal to 2m, C over 2m omega. So from this equation, ano naman tayo psi, we have the mass, we have the natural frequency or the natural angular frequency. The C or the damping coefficient is just equal to 2m omega psi. Matik na. C is equal to 2 times the mass na 1,223.242 kilograms. Then times we have the omega na 25.206194 radians per seconds. And psi na 0.037347. Ano na tayo coefficient, damping coefficient equal to 2,303.06055 kilograms per seconds. So ang unit na to ni damping coefficient, it can be kilograms per seconds or Newton seconds per meter. And finally, solve na din nato si damped angular frequency that is equal to omega square root of psi squared 1 minus psi squared. So we have the 25.206194 radians per second times square root of 1 minus 0.037347 squared. Omega t. Our damped angular frequency is equal to 25.188609 radians per seconds. Na. You have any questions or clarifications on this steps? Actually, dali na siya, no? You just have the formula and then depending na sa may paggamit. And before we end, you'll have an assignment. Please take a screenshot of this one. This is the problem 1. And then, this is problem 2. Problem 3. And problem 4. Okay, so that's all for this evening, no? Yes, Mr. Batoy?
Sir, pila ka decimal sa mga i-consider, sir?
Kuan, 6 decimal places. I will post one of further instructions sa Google Classroom. I will also upload the detailed solution at the general solutions sa ang kuan, equation of motion, and as well sa atong i-discuss this evening. So that's all for tonight. If you have any questions or clarifications, you can send me a personal message sa Messenger, and I will not hold you for too long. No, we are already over time. Yes, Mr. Batoy?
Sir, klase imong quiz, sir. Solving ka ng, sir, ba?
Amot lang. From the start mo ng kuan, coverage.
Okay, sir.
Pwede siya nga, basin kuan. Depende. Ang deadline sa assignment is Saturday morning. So mag-post ako sa Google Classroom for the assignment. Okay, so that's all for this. Sa Mantobiano.
Ay, sir, kanang pwede kang pabalik kang kadjut sa katong slide bitaw, sir, katong sa B ug C nag-solve.
Okay. For a while. Nara. And Nara. Okay na to? Tapos,
Yes, sir. Thank you, sir.
okay na definitely. Okay. Other concerns? Other concerns? Yeah. Having hearing none, let's meet this Saturday. CanCon. Let's end our class. Let's end our discussion. I will not hold you for too long. See you this Saturday. Have a great night ahead. If you have, you can take your dinner na then, and that's all. Have a great night ahead, and goodbye, everyone.
Thank you, sir.